Good day, students. I hope I find you well. Today, I just want to look at this structure which you find on the whiteboard. I'm just going to revise organic chemistry revision as part of your revision for paper 4, which used to be called paper 3 in Igcse, SC at level chemistry. Now, on the board, I've drawn a structure here. It is a hydrocarbon because it consists of carbon and hydrogen only. So it has 1, 2, 3 carbons, and it has 1, 2, 3, 4, 5, 6, 7, 8. So it's an alkane. So we call this one propane, okay? 3 carbons and 8 hydrogens. So let's subject this organic hydrocarbon to a reaction where we are going to have chlorine and UV light, okay? Obviously, you can tell that this is a free radical reaction or free radical substitution. So what is going to happen here is we are going to remove one of the hydrogens and replace it with chlorine. So at the end of the day, we are going to form a compound whereby one of the hydrogens is going to be substituted, okay? So we are going to come up with a compound which could behave in this structure, okay? You can see the hydrogen was substituted by chlorine. So it's a substitution reaction, but we need chlorine and we also need UV. So that's why we call it free radical substitution. So this one is called propane, okay? This compound, we call it propane, all right? But now our propane, one of the hydrogen is substituted. So we now have chlorine on carbon number 1. So we are going to have, this one is now 1-chloropropane, okay? We have changed our hydrocarbon to a halogenoalkane, and we have done that using chlorine in the presence of UV, okay? So this is 1-chloropropane. If you are asked to write an isomer for 1-chloropropane, all you have to do is to shift chlorine and you put it on carbon number 2. So in this case, we can have 1-chloropropane. If you put chlorine on this carbon, okay, we always count from the lower end. Again, it's going to be 1-chloropropane, okay? But take note, we have substituted hydrogen and chlorine. There are 2 atoms there. So it means this is not complete, all right? One of the chlorine is going to react with the 1 hydrogen, which is going to be substituted here. So we are going to have hydrogen chloride also being emitted in the reaction, because we have 2 chlorine atoms and we have 1 hydrogen here. 1 hydrogen is going to react with one of those chlorine atoms, and then we are going to have HCl, okay? So we are going to have 1-chloropropane, and we're also going to have HCl in the reaction mixture, okay? So if you're asked to draw an isomer for that one, you can do this, okay? You can have your chlorine in the middle carbon or carbon number 2, and then you are going to have 2-chloropropane. So 1-chloropropane and 2-chloropropane are isomers, chloropropane. These are isomers. So when this reaction takes place, you're not going to produce a pure mixture. You might have a mixture of isomers. When you come to A level, you are actually going to use some rules to predict which of these isomers will be present in larger quantities. I thought I could just revise with you basic concepts of free radical substitution, whereby a hydrocarbon which is saturated like propane is reacting with chlorine to form 1-chloropropane, and in this mixture you're going to have 1-chloropropane and 2-chloropropane. These are going to have the same molecular formula, but they're going to have different structural formula. So if you are asked to write the molecular formula, it's going to be CH3 and then 7Cl, okay? So 2-chloropropane and 1-chloropropane, all of them are going to have this formula. They are isomers because they are going to have the same molecular formula, but the way the atoms are going to be arranged in space are going to be different. I hope you have learned something from this short revision session. Thank you.